All right. Well, looks like we'll go ahead and just dive in, and if we get some people joining in late, we'll get them caught up. All right, let's go ahead and thank you everybody for joining us today for BIM 6D, BIM and Sustainability. This is part 3 to our sustainability webinar series, and this is called Sustainability for Systems and Analysis. Today's host is Jim Cohen and myself, and it's brought to you by our Co-Innovation Lab. And within our Co-Innovation Lab and through industry collaboration, we explore, which is an ongoing process, and implement multiple methods in which BIM can make design more sustainable throughout a building's life cycle. The reason we do BIM is to encourage more innovative and cost-efficient designs, which buildings and buildings by collaboration for more integrated information exchange. But before we go ahead and start today's session, I would like to go ahead and just give a quick agenda and say a few words about who we are here at Microdesk. All right, next slide, Jim.
Looks like we've got a bit of a delay.
Okay, I'll just
be on the agenda.
Yes, it's slowly changing. Okay, perfect. All right. So just real quickly today, we'll do a Microdesk and presenter introduction. We'll recap part 2 and part 1 briefly of the systems analysis or the building performance analysis, and we'll go over about a little bit of the model setup and the workflow. We'll define the analytical systems and explain kind of what those are, and then we'll run a systems analysis and review the results. If we have time at the end, I think Jim has a little something extra for you guys, a little demo for some new tools as well, and then we'll call for action at the very end and have a Q&A just in case. All right, next one, Jim. All right, so we'll go a little bit over who we are here at Microdesk. Here at Microdesk, we've been innovating project delivery for over 25 years. We've been steadily building upon our foundation, and we're intent on building a sustainable future. Our services range from an array of workshops, project support, project management, and lots more. We offer over 230 AEC experts that range from registered architects, professional engineers, construction specialists, and application developers. Additionally, we have teams dedicated to IT, advisory, and asset management. So with Microdesk, we have the vision, tools, and talent to help get your firm to the next level and the future cities. And real quick, we'll just go over a brief slide, a little bit of our clients that who we work with. This is just to showcase the wide range of skill sets we have here at Microdesk. Work with companies like Walt Disney Imagineers as well, all the way to nonprofits like Built Health International, to high-end design firms like Gensler and Foster and Partners, as well as Grimshaw, even to electrical designers like Cupertino. Wide range of skill sets and professionals that can get integrated in every aspect of your project as well. Next slide, Jim. All right, and so bear with me, guys. I'll just kind of allow for the lag to catch up. Hopefully, it's not too slow. Can you guys see the next slide, Jim, or is it
it's showing on my screen? I'm gonna go back. It's the
there we go. All right. Yep. So Microdesk, we're industry-leading partners. We're also like Autodesk Platinum partners, IBM Silver, Panzera, Esray, Eagle Point, Inkscape partners, as well as a Bluebeam Platinum partner. And what Jim will show off is we're recently partnered with Unity as well, so we'll showcase with that stuff as well. All right, next one, Jim.
Yep.
All right, so this is our entire sustainability team. On the left, we have Shivani. She's the R&D lead, and then we have Eve Clark, myself, Luke Wing. I'm a Revit professional, building performance analysis certified through Autodesk, as well as a Revit professional through Autodesk, and a sustainability evangelist. Today's presentation will be given to you mostly by Jim Cohen. He's a BIM consultant and a trainer with over 35 years of experience. He is an AEC expert and a sustainability author. And I'm sure I can let him introduce himself a little more. You wanna jump in, Jim?
Yes, I'm going to present, but I just want to give some credit to Vasuda Dixit, who prepared a lot of the content.
Perfect. Absolutely. Yeah, Vasuda was our mechanical engineer behind the scenes for us. All right, and then let's go to the next one, Jim.
We should be on globalization or drive.
Oh, perfect. Well, I'll go ahead and just start speaking to that and whenever it pops up. So here at Microdesk, our drive is, and we understand that the most important factors in today's industry are going to be globalization, urbanization, and sustainability. And our drive at Microdesk is to build upon that culture, which revolves around transparency and encouragement. That's thus enabling us to integrate a digital delivery for our clients worldwide. So we hope to translate this into our culture and into our services, as well as the products we provide for our clients, and for the built environment as well. So focusing on these three main factors, we understand that technology and science have been a major driving force in the globalization factor, and it will be driving the standards of living across the globe. And urbanization is that 2.5 million people will be moving into these urban centers in the next 30 years, and will grow from 28 to 43 megacities by the year 2030. And on the sustainability front, we know that cities consume about 78% of our global energy. That gives us the maximum room for opportunity for change here in our AEC industry. So we must address climate change, and it requires reimagining the built environment, but support from global sustainable initiatives as well. Which brings us into the next slide, which is about BIM dimensions. So how sustainability fits into the world of BIM. And I'm sure it's popping up just a little slow on my end, but what the BIM dimensions are is just how we are defining and outlining the process of BIM from cradle to grave, right, and beyond. So where sustainability fits in is technically 6D, but we want to reach beyond that, do 7D, which is the asset management, the as-builts, and even getting onto lean construction, where it may be instead of demolishing, we're being able to renovate, recycle, and upuse all our buildings as well. But we can implement all these strategies through each design phase. So even through design definition, preparation and design, which is CDs usually, concept and schematic design, and all the way through the life cycle of the project. So on the next slide, we'll just showcase our Autodesk building performance analysis capabilities. So here at Microdesk, we have the abilities to help you benchmark and get your EUI within your BIM. And we also have the ability to do solar insolation within your Revit model as well. The daylighting illuminance within your Revit model. And I keep saying this over and over again because the more integrated with BIM and keeping the eye and the information aspect in there, the better we're going to be in the end result. So I really push for the single source of truth and having BIM. So again, going through the lighting, we have interior daylighting for lead version 4 through Revit as well. And then we also can do renewable PV energy and get estimated payback times and also estimated productions. We can do building envelope heat transfer. We can do this in Autodesk CFD to extend it to your suite, but there's also free softwares out there that we can help guide you and get you your envelope heat transfer studies as well. We can do wind analysis with flow design and with CFD. There's, again, other external tools for this, but just to get you started, we have all this within your Autodesk suites as well. And last but not least, the new kid on the block, the one that everyone's talking about, is Dynamo and generative design. We have capabilities for generative design through Dynamo, and we also are using this to leverage sustainable design as well. So understanding which inputs are going to leverage our building the best and give us the best head start from the beginning. All right, and next one, please, Jim. And so I know as much as I am support of the single source of truth and keeping it within Autodesk, I understand that we at Microdesk understand that these building performance analysis capabilities, they go beyond Autodesk products, where we can really start to dive in and indulge into these buildings and really understand what our analysis are trying to tell us. So Autodesk products get us to a certain level, but then there's products out there like Light Stanza, where I would say we would vacate the lead studies from the Autodesk products and move into Light Stanza to really get quantitative data. And that's what a lot of these tools here are showcasing. Aurora Solar can give you system for PV design, which you could hand to an installer and understand down to the penny for your area code of what kind of PV designs and what's available to you. Cove tool, Rhino, Grasshopper, Sapphire, all these tools are wonderful, and they are all good for their certain implementation or where they're implied. But the right tool for the right time is where we were trying to help you guys out. We got to get the best fit for your workflow. All right, next slide, Jim. So we'll just kind of briefly go over part 1 and part 2 of our sustainability webinar series. We started off with the NRG Stadium and the Astrodome Master Plan, and we were just looking at a multifamily complex, and we were going to understand the building performance analysis through early conceptual design all the way through the more schematic and detailed design, which the phase we're going to go over today, where we start looking at systems analysis. On the next slide, please, Jim.
Yeah, so the plan today is to look at a Revit systems analysis, which is a set of features that allows a mechanical engineer to define the main components and set of relationships that comprise a building system. All of this without having to physically model any part of it. It's built using Energy Plus and Open Studio in collaboration with the US Department of Energy and the National Renewable Energy Laboratory. When you model in Revit to run the analysis, you export the data to Green Building Studio, a GB XML file. And then you get from Open Studio, it takes that information from the GB XML and gets it into Energy Plus. Energy Plus then runs a bunch of simulations, which can then produce the reports. The idea with the systems analysis workflow in Revit is that you define systems such as a water loop. You create equipment, say heat pumps, and you assign them to the water loop system. In this example, all we're showing is that we have, say, separate apartments in our building. In this example, apartment 101 has like an east zone and a west zone. And the idea in the loop here is that you can see that where there's a connection between the model and the building systems that we've got analytical setups for. Just to review the way the model was set up, after we linked the architectural model, one of the first things we would do would be to set up the geographic location, the direction to true north. As you can see in here, if I just get this to run, we can go to the Analyze tab, we can pick our location. What you're seeing is the linked models that have the content in it. So we're able to take the architect's model and create really a copy of the things that are important to us. Where we look at the weather station, it may or may not be the case that that's the best location for you. You don't have to pick the nearest weather station. You can also uncheck the box and, oops, sorry, moved. I'll start that again. We're having some lag time issues there. So setting up the weather station, what I wanted to show is that they're generally within 8 miles or 12 kilometers of the site. You can pick the one that you want. We've got the NRG Stadium in Texas. But if you go to the weather station itself, you can also uncheck the box that is the use HVAC design data, and you could enter the specific values that you want for the study. So you're not limited by what is offered in the defaults. You can kind of overwrite them and provide their own values. The next thing that we would want to do would be to actually bring in the elements of the building that are important to a study. And I actually used this model for several different things. Light analysis using a rendering engine. We can use a transfer project standards and bring in the architect's walls and floors, windows, and so on. And then we can use copy monitors. So that in this approach, what would happen is if the architect's model changes, update it. But by bringing in his actual walls and floors, we're making sure we've got the correct volumes in the building. We have some quality assurance views where we can look at the different floors of the building and just confirm that the model is as we wanted it to be, where we're seeing walls in red, floors in blue in the windows. So if I move forward with that, we're able to assign material properties with the U values using schematic type. So now that we've got the building model or a copy from the architect's model, it can be updated anytime we want. And when we submit for energy analysis, the option that we could use is to tell it, what the building type is, and then override any of the building elements with the U values that are required by code, in this case in Houston. I'm having there's a little bit of a lag time here. So it might be that the architect, when he's working on energy analysis at a very early stage, has massing forms and building elements superimposed on them, and these are used to imprint on where the openings are, and you can do an energy study. It's more likely that the MEP systems analysis or energy analysis will get involved when you want to have the building elements there and you're applying schematic types to override all the values for the U values for the building elements themselves. There is the option of using detailed elements that would override anything else. That's a little checkbox when you submit that would say use the actual material that's in the wall itself. These are a little problematic. Also, I've run into situations where we have like a hospital or something. It's so old and been on the go for so many years that it may not even have thermal properties under the material. You would actually have to introduce them to the material and assign, values that you want. There are cases that I've seen where people have created their own wall types that are the same size as the architectural walls and assigned the material with the U values that we want, especially when they have like a special exterior to the building, maybe some kind of glass facade. So there are occasions where this would be valuable in creating the study. We set out to specify what our building type is. So you see here it says multifamily. In this first scenario, we've got like residential units in the whole building, so we just need to assign building type, and any analytical spaces will be classified as multifamily. We don't have internal walls at this point, so what we're doing is just kind of kicking off a study, telling it it's multifamily, and producing our output from the reports. If I look at the study here, this is what we can, we've got the Revit model, our single source of truth. We've got the energy model that's in the file, and we can have quality assurance views to look at the assignments. We have our systems browser that will show us what systems we've got, and we've got output from the software on the performance of the whole building, or in the heating and cooling loads for individual rooms or spaces. If I move on with this is where everything is a single apartment, and we want to make sure that the system browser is available to us and that we're able to define systems. So on here, what we're doing is looking at the system browser, only available to you if you've got MEP on your interface. Then we can do things like define a building system, say adding a water loop. There's already one there. This is just to show the process. And you can define what it is. Say it's condenser water, just delete it. So we've already got the building system. Then what we want to do is define zone equipment. So we can create zone equipment, give it a name. We're calling it, apartment 101, 102, 103, 104, and defining which system it belongs to. We can then go to the critical part, which is what we're doing is we're going to system zones. This is where you would actually draft a line. Anything that crosses, if there are spaces in there, it would collect them together to know that these are supposed to be associated with the equipment that you've got in the model itself. As long as the lines intersect the space, they can be assigned to the respective zone and you can give it a name. So in our example here, when we kick off the model, it gets the loads from any spaces that are in there that have the ASHRAE standards for the different spaces. And then we can kick off reports to get some quantitative output from our model itself. These take a while. It might take 15, 20 minutes before I get a report. You can give it any name that you want. It'll put it in two locations. It'll put it on your project browser where you can go to reports and look at it. Or it'll also create a subfolder below where your project is, and it puts files in there that you can also look at. So in this example, I'm not sure that moved forward. There we go. So in this example, what we're doing is we selected I think this is the one we just saw. It is. Let me go to the next one. So this is all single apartment spaces, and what we're doing here is we've got a system browser up. Sorry, I've got a lag time, so I'm maybe seeing something on my screen that's different from what you're seeing. Don't know why we're having this. Okay, let me jump to this one just because of time. We've got here I've got the same model, but this time what we did is we set it up so that we have spaces, and we're going to show how that's created. There's a space naming tool that will convert any rooms that are in the project and generate spaces from them. We'll also have a space schedule, and in that schedule we can assign the space type. So where you've got mixed use, for example, if you were doing like a remodel, you would need to have spaces in the model so that you can control the loads for those spaces. Where it was all one activity, we could just say buy the building, but where it's mixed use, we need to have those spaces and assign zones. So if I just show on here, we've linked in the architect's model again, but the architect's model now has interior walls. We can use the space naming tool to say, take the architect's rooms and generate spaces with the same name throughout our project on the levels that we're interested in. And then we can have a space schedule so that we can actually assign via the schedule what the space type is, or other data from our Revit model. We're ready to define the system. There's one already defined there, but what we're seeing is the line work that was drawn is making the association. The reports were kicked out, and the reports would show up and give us the building performance, where we can see data on a detailed report or a second report. There's also a content page where we can link to the data that's inside our model. So you can see that the cooling loads are the biggest component. We can review the HVAC system loads and sizing report and see the zone component load summary with heating and cooling sizes information for each of the analytical zones. Let me move a little forward on this. I'm getting a huge delay on my system here. So the reports are output and they're saved in a folder, but they're also on the project browser, and you can look at those results. And what we found was that when you've submitted the model to Insight, you can have from the triangle the system that was designated for the model, and you can have with the circles options that were created in Green Building Studio. So what we looked at was initially we used a heat pump. We saved that, as a scenario, and then we did an option where we looked at the better performing heat pump to see how much energy we were going to save in the building itself. So we're using that single source of truth to work with our model. The thing that came home to me strongly in working with the single source of truth is that it applies to a lot of different things that are germane to sustainability. So for example, here, what I'm doing is looking at exactly the same model that Vasuda had, with retail on the bottom, apartment units on the top, building elements. We've got, looking now at the lower floor, we have retail, color overrides just to make it clearer what we're looking at, to check our energy model. And there's the top floor. If you remember in previous presentations, we did illumination studies on the top floor, on the bottom floor from with Inside Revit. We had Jeffrey Tiers model some additional shading, and we put that into the model. We knew it was efficient from the feedback he was getting. Now what I'm going to do is send it that single source of truth, that model that I've got for energy analysis. I'll just call it lighting study. I can choose whether I want to include interior lights. I'm just going with the defaults. This would be kind of like view templates where I can decide which categories are being saved for the study. So for example, when Jeffrey added the generic model, it was the shading. I can include that as part of our lighting study. I can save up the whole model, or I can do it individual rooms or individual floors. And I can choose spaces, which was my default there. So it might be in a project that really I only need to look at one or two of the apartments. I don't need to do them for all of it, but just to see how much time it was actually going to take. If I said I want to take all of the floor levels in the building, all I need to do is just to check them on, instead of drilling down below that to pick like an individual room. I can submit the report. It's the study. There's a connection between this model and the study. So for example, if I modify lighting or something in the study, interior lights, I can send that back to the Revit model based on the analysis of lighting within my building. I'm going to turn off the interface just so that we see the views of the building. If you're a Navisworks user, you know that cameras are referred to as viewpoints. It's kind of similar in here. I can have different viewpoints to look at my model. This is not edited, so what it's done is it's picked up the location from the Revit model. It didn't require that I go and submit for each individual study what kind of logarithmic scale I wanted for the lighting. It's got defaults that I can establish for my project at the beginning. I want to use imperial units, what range it is. If I go back in here, I can say what I'd like to do is any one of those studies. So the idea is that next year would present fuller presentations on how you can use a single sustainability model to do multiple studies. So previously what we'd done was look at the fall solstice. Here I submitted for 9 a.m., 12 a.m. and 3 p.m. in the afternoon. I renamed my report, Illuminance September Equinox. I can look at the floor plans in my building. So I've got views where I can go look at my multifamily or my retail. And this is actually recorded, just saving the report. So as I look on that on the right-hand side, the progress bar is telling me that it's creating the graphics for the report. I can click on the view to view it in the model, and I can see the illuminance report for each and every floor of my building. And if I zoomed in a bit, you'd see that it's actually got the light levels showing in the interiors. I can go to as small as a 6-inch grid. And it also will give me more reports that I could work on as well. So the idea there would be that we've actually got, from the same model that we used to use the energy analysis, we're able to go and do lighting analysis in our project. The other one would be using a rendering engine. So we have other teams that are exploring using, so there's something not moving forward here. So it's misbehaving somewhat. So I mentioned we've got another team that's looking at using Unity with Reflect, or Unreal with Twinmotion. We're exploring all of the options. But again, it's the same model. So if I wanted to produce something that was maybe augmented reality or virtual reality, or I wanted just to improve the presentation quality of the proposals that we're looking on for sustainability, I could use any of those tools. So for example, if I bring up from this model, the study that's created, I can update that anytime that the model changes, but I can have saved content in here. So there's my Houston project. The kind of thing that this is going to let me do is change materials for presentation purposes. A large library of photorealistic materials where I can pick a material and simply drag it onto a surface. I can search for items, like I'm looking for a different glass. So the analytical part would be done in something like Stanza, where I can control the properties of the glass. The visual part of it is something that if I needed to enhance it, I could enhance that in a rendering engine. But I've got everything coming from the one model. So if that one model changes, my virtual reality model would update, or if my lighting changes, in Revit, my lighting models would update. So we're looking at things like what impact would green roofs have on our building. So the kind of thing that I could be doing here, apart from modeling it, in Revit, would be that if I want, I can turn on and off the display of objects in my model. And then what I want to show here is that combining all the tools to use, best features, I can add animations with paths. For example, our sustainable advocate who rides bicycles everywhere. These have properties in here where we can do things like increase or decrease the number, change the speed. So I'm trying to just think of, you know, how all this relates as one connected model for sustainability issues. So thinking about maybe putting in a roof garden of some sort, what I can do is I can collect vegetation. So I want a green roof. I could go and look for, say, small bushes. I could go search and get some grass. Typically, I'd be looking for sedum species and doing a unique built-up roof with correct soils and so on, irrigation, proper seal from the rest of the building. All I'm trying to show here is that I can paint the surface and I can change the diameter of the tool that I'm going to paint with. So what I'm doing is just kind of adjusting the size and dragging over the surface to paint a combination of these species onto the roof itself. So I'm getting that planting mix, if you like, as part of my study. Drop it on the ground, put it any place that I want. So that would probably be a roof system in Revit that has the seed mix in it, and for quantitative reasons, but for visual reasons, I can illustrate it in this model. I've got media where I can have, if you like, saved camera paths. You saw us use Enscape and other products in the past presentations where we did things like measure illuminance, measure foot candles inside a building. But what I want to show here is the ability to actually, with these rendering engines, Unreal or Unity, change the season. So I could go into a particular saved session and decide that, okay, what I want is summer or frequent rain in Houston, certain times of the year, bright sunlight. I can change this for that sequence of the animation. I can even, if I want, I can pick, say, winter season. So I'm seeing snow on the ground. And if I do winter season, but I also say that I would like to have different weather. And if you look carefully, you'll see that the plants themselves actually change to show fall color, or if they're deciduous. I can even, they would change with the season, and I can grow the plants. And then I can export out videos to present to a client from whatever the settings I have in here. So exporting it out, and it rendered it, and it took about, put it in a particular folder, and it took about 10 minutes. And then I can come back with my output movie to explain my proposals to the client. So the main takeaway should be that I've got a single source of truth inside Revit, but all of the different tools that I have available will let me use that data to do systems analysis, to do lighting analysis, to do augmented reality, and many other options. So that was where I wanted to switch back. I apologize for we're getting a lag time for some reason in the presentation. Luke, did you want to kick in here, or?
Yeah, perfect. Sorry, thanks, Jim. So yeah, just to kind of sum up, the point that Jim was making is that, it's about using the best fit tool at the right time and being able to leverage that tool's best ability for your analysis, and understanding how all these tools are interconnected, and when you make an adjustment somewhere, how it affects your other parts of your analysis. So through part one, And part two, we leveraged all the building performance analysis tools that maybe an architect would use and leverage through early design. And then Jim started getting into where the architect and the engineer starting to engage and start that conversation and really start to push these strategies into reality. But the ultimate end goal here is to understand that Microdesk, we are here to help you, support you, and help you implement these strategies. And we believe in integrating sustainability into these strategic initiatives is especially important because the issue plays out over the long term. And we support our clients in aligning in these goals and strategies from the very, very beginning. Our goal is to educate and advise throughout the entire life cycle, from designers, owners, and in demand, make demand higher performing buildings, right? We want to create this demand, create work. So within our co-innovation lab, we have a dedicated research and development team, and we have a very robust process that will help us discover and implement the right workflow to suit your firm's needs. And we do co-research, co-create, which allows us to co-innovate. So we're working with you, we're not just doing it for you. Well-versed in a wide range of analysis software, and we have the right tools for analysis needed, as Jim just showcased for you guys. And we have the ability to develop tools as you need them as well. If there's not a tool out there that suits your workflow, let us know. We can create that, and it could suit your workflow and get the data and suits the issues that you guys are looking to support. We also want to support an early and holistic integrated approach, and we have a large platform with a multitude of resources to help tackle all the industry present and future initiatives and goals like ARC 2030 or any of these sustainable initiatives, pretty much like LEED. But Microdesk will foster and we promote a collaborative process. That's the main point, is collaborative, with the most innovative solutions to help grow and reach beyond your firm's goals and leverage BIM to its fullest potential. So now the time, next one, Jim, is where we like to do the call for action, right? It's time now that we all come together and we take responsibility as an industry and as a community. We need to develop standards and obligations and have shared ethics. We need to develop our credit sharing and full transparency. No more, this is mine, that's yours. It's got to be open source. We have to have a fresh input with aligned goals. We need to understand our skills. We can do shared knowledge and experience and discover new approaches and tools, like Jim showcased today. But you have to have the confidence and the ability to innovate and collaborate within our industry and be open to lean and learn on from others. So with that being said, always feel free to reach out to Microdesk. We can help get you to your initiatives and your goals, because at Microdesk, our main goal is to share and have a transparent industry where we can work together to get these initiatives tackled. Next one, please. And this is really just letting you guys know that we know that more is inevitable, less is going to be a reality, but there's always an opportunity of better if we work together and collaborate as a team. And that's pretty much all we have today. You want to go to the last slide, Jim, so they throw the contact information up there.
Sorry.
No, it's okay. No worries. I know at the bottom right left-hand corner here, my LinkedIn and my Twitter is there as well. I'm sure you just look up Jim on LinkedIn, you can find him. But you can contact Microdesk directly, or even at our co-innovation lab email as well. So with that, we'll open up the floor to any questions, and we'll be more than happy to spend some time and go over that with you.
Or if you want to enter into the chat box any topics that you want to see addressed as part of a sustainability effort, because we're thinking about what we want to look at and what we want to present in a small series of webinars beginning in the new year. Are there any questions? If you could type them in, or
let's see. I don't see any in there yet, Jim. So Jim, just I guess since we're on here, I'll just kind of ask you a question since I wasn't too involved in this part. gathering the information from the architect's model and bringing that over to the IME, to the I guess the engineer's model, correct? How was that process for you guys? Were you involved with that with Vishuddha? Am I not connected? Is everybody, Jim, can you hear me?
Sorry, yes. Oh, sorry. I was, for some reason, it was muted. So yeah, the Vishuddha did the copy monitor. What I said was that the benefit to it was that we could exclude items in the architect's model that we didn't need, like room bounding objects like columns that would have affected the volumes in our calculations, or specific things like floor finishes, where we really didn't need that for any of the studies that we were doing, carpet and all of that thing. So I have done it in the past, and I had some issues where the architect's model would change with additional windows in walls, but they wouldn't update easily with the copy monitor process. But there was always a workaround where you could copy and paste things from one model to another. But in this case, it worked very well because we started with a building that was really just individual apartment space. And then as we added the internal partitions and closets and things like that, Vishuddha could update the model, and then she could decide what spaces were conditioned and what weren't conditioned and how they were zoned, and was able to look at really for the warmer side of the building having a different set of heat pumps than for the colder side of the building. So it was flexible in that regard. Okay, so I don't have anything to add here. So I think if there's no questions, I think we can close the meeting. I'm going to look one more time at the chat just to see if anybody entered any questions. Nope. Okay, so I think we'll call it quits. If let us know about potential future topics that you're interested in.
Thank you, everybody. We appreciate you guys joining today.
Okay. Bye.
Thanks, Jim.